We are going to talk about the intermediate value theorem. And the intermediate value theorem is a theorem that says if you have a continuous function, we call it f, in the interval a to b. So that means it starts somewhere on the x-axis and ends somewhere else. And n is any number in between the y values for those. So let's say a is here and has some height up here. Maybe that's a height of 3. And b is here and the height is here. Maybe that's a height of 1. N has to be in between here. So if this is 1 and this is 3, then maybe n is 2. Something like that. What it's saying is that for every height in between f of a and f of b, every height in between, for example, n, there would be a spot on the function and there would be an x value for that spot. And the x value would be between a and b. So if you have two heights, for example, again, 3 and 1 for your function has a low or a minimum of 1 and a maximum of 3, then there will be every height in between, for example, 2, and there will be an x value that would create or have the output of that y value of 2, or in general n. So that is an intermediate value theorem. We are going to use it to show that a polynomial has a 0, which just means, not actually finding the x value, but just showing that there is one. And then in the second example, we'll actually find it. So the intermediate value theorem, first you have to make sure that the function is continuous. So is this continuous? We start with that. So the function here is f of x equals x cubed plus 2x minus 1. That is a cubic function. Cubic function is an S-curve. There are no holes or jumps or asymptotes in an S-curve or in this cubic function. So yes, it is continuous. Then we have to show on the interval 0 to 1, would there be a 0? A 0 is an x-intercept. An x-intercept would be, having a height of 0. So we need to show that from x equals 0 to x equals 1, that it goes on either side of y equals 0. So I don't have this graph. I mean, we can graph it, but what I'm looking for is at x equals 0 and at x equals 1, is there a y-intercept somewhere in there? And the only way that we could guarantee that is if, at x equals 0, maybe we're below the x-axis or y-axis, and or below the x-axis, sorry, and then maybe at x equals 1, we're above it, and then we'd have to go, and there would have to be an x-intercept in between them. Or maybe it starts above, ends below, and so it would have to be, have an x-intercept in between there. So that's what we're looking for. So how we're going to do that is we're going to first find f of 0, then we're going to find f of 1, and we're going to see what those heights are. So if you plug in f of 0, it would be 0 cubed plus 2 times 0 minus 1, that's negative 1. So 0, negative 1 is here. And then we'll plug in 1. 1 cubed plus 2 times 1 minus 1 is 2. And so 1, 2. So if you have a smooth continuous curve, which we do have, that means they're connected somehow, there has to be a 0, which is an x-intercept, right there, in the interval 0 to 1. And because it starts below the x-axis and ends above the x-axis, it has to cross the x-axis. There has to be a 0 sometime between 0 and 1. How we would finish writing that is we would say, yes, there's a 0 between 0 and 1, because f of 0 is less than 0, and that's less than f of 1. And those values were negative 1 and 2. Now, when we do the second one, it asks us to actually find it. So we could find what this value is if they asked us, but they didn't ask us in this question. So we'll do the next one. Verify that the intermediate value theorem applies. So is it continuous? That's our first question. We'll look at the function. It is a quadratic function, which means it's a parabola. So I would say no question mark. Yes, it's continuous. It's continuous from 0 to 5, which is where it's important, because that is, you know, the domain, the restricted domain that we're looking at. And then it says find the value f of c, find the value c such that f of c equals 11, guaranteed by the value. So here's what we're going to do first. First, we're going to plug in 0. Plugging in 0, and then plugging in 5 will give us the height at 0, or the y value at 0, and the height or the y value at 5. So first we'll plug in 0, and I'm going to get 0 squared plus 0 minus 1. So I get negative 1. Then I'll plug in 5. 5 squared plus 5 minus 1, I get 29. So because negative 1 is less than 11 is less than 29, 11 is the y value that is in question. Because negative 1 is lower and 29 is higher, there will be a y value or a height of 11, and we have to find the x value that is associated with that. So again, if we read the question, verify that the intermediate value applies to the interval 0 to 5. So we did that because it's continuous and because the y values surround the y value in question, which is 11, the intermediate value does apply. So then we can go ahead and find the value of c such that f of c is 11. Because 11 is a y value, I'm going to take the function and set it equal to 11. And then what I'm doing is I'm looking for a c value for x such that the y value is 11. So I'm looking for what x value would give me a y value of 11. So I set it equal to 11, and I'll solve. I'll plug in c to keep it consistent with the letters that they're using. So I'll do that. If I minus 11 or subtract 11 from both sides, I get here, and then it's quadratic, so I'll factor. Looks like 4 and 3 would be good. So I get negative 4 and positive 3 as my c values. I am looking at the interval 0 to 5, and so since negative 4 is out of the interval, I don't include that in my answer, but I will include c equals 3.